1.1 solving equations, triangle. So in our example, we are given a triangle, some kind of triangle, and in that triangle we have a 40 degrees angle, and sometimes they're written outside so that they're kind of because there's not enough room in there. Then we have this one has a 70 degrees angle and an x degree angle. So we know that the triangle sum, meaning the total, so sum means the total of a triangle is 180 degrees. Sometimes that will be given to us, sometimes we just have to know it. So that means the sum gives us the Q. Sum means add, so we're going to add all of these up. So when organizing our equation, what we're going to do is add them up, just add them right in a row. So we have a 70 degree, a 40 degree, and an x degree. So we go right through it, and we know that by adding that up, it is equal to 180 degrees total. So we've written our equation, and this is setting up our writing equations, and it's going to get more and more complicated. So what we want to do is practice that writing, that setting it up, because I know you already know how to do this just kind of mentally and solving it like offhand and just kind of like jotting a few numbers down. But what we want to do is to really focus on solving the equation. Now, these two are like terms, so we want to add them together. They're on the same side, so we don't have to minus 40. We could minus 40 from both sides, but I'm going to add them together first before I zero them out. So remember, we're getting x by itself. So this is one step to getting it kind of nicer, a little cleaner. And to zero the 110 out, we'll subtract 110. If you do it to one side of the equation, we have to do it to the other. So bring down our x, because that's x plus 0 over here. So just x. Bring down that equals. And 180 minus 110 is 70 degrees. So we calculated that x equals 70, and it's degrees, it's an angle, so let's put that little label there right there. Now, when we get more complicated equations, they seem harder, but I'm going to show you a nice little trick to be able to use, and it works exactly how you already think mathematically. So we've got 4 equals negative 0.8 m. So I notice in this one that I have this multiply by this number. So to cancel that out, to undo multiply, we divide, and I'm multiplying by a negative 0.8. So I'm going to divide by a negative 0.8. And if I do it to one side of the equation, I have to do it to the other side of the equation. Now, this is where it gets tricky. Some people are like, well, let's just slow down. I know that equals 1. So what I'm going to do is bring down my equals. And notice how I just bring it straight down. Now, m is on the right-hand side. So I'm going to keep that on the right-hand side. And now I just have to think about this as a fraction. Now, simplifying normally would be nice if it was just the 4 and the 8. Well, that gives me a clue to what we need to do to make it easier to solve. So I'm going to do a little sideline math. And I've got that 0.8. And I was thinking, it would be a whole lot easier if I make this denominator an 8, which means moving that decimal over one place. To do that, I need to times it by 10. Now with fractions, though, if I multiply the denominator by 10, I have to multiply the numerator by 10. And that's that 10 over 10, which is a 1. So I haven't changed the value of it. I've just changed what it looks like, what we call the form of that. So 0.8 times 10 is 8, and that's why I wanted it, because it's a lot easier to do. But now up here in the numerator, 4 times 10 is 40. And 8 goes into 40 5 times. So 4 divided by 0.8 is 5. And normally a lot of people would circle it right out, but we remember, watch out for that negative. So a positive divided by a negative is a negative. So m equals a negative 5. Now our last example, number 3, is 6 equals negative w over 8. Now, what's tricky about this is that it's divide by 8, which we know what to do, but there's this negative. Now, this is the way the textbook likes it out front. Now, that's one way we could write a negative. Another equivalent or equal, we could move that negative up to the w, and notice that there's one negative. There's one negative, we have it out front, one negative is on the top, or if we want to, we could move that negative down with the 8. But notice that the w is positive. So wait, I do like to have, when I solve this, I do like to have my w be positive w. So I think I'm going to use this one for this problem. So that negative 8, so I'm going to rewrite this as w over negative 8, bring down my 6. So sometimes I like to rearrange it because when I solve that divide by negative 8, to undo that, we multiply by negative 8. And if I multiply one side by negative 8, I multiply the other side by negative 8. Now notice I put it into parentheses because I want that negative to be a minus, and if I didn't have that negative there, it would look like a subtract 8, and I don't want it to look like that. I want it to look like a multiply by 8. Now, that means those negative 8s divided by negative 8 cancels out to be a 1w, a positive 1w, and negative 8 times 6 is 48, and it's a negative because a negative times a positive is a negative. And that's how we solve equations that are a little bit more complicated and the triangle problem.